Hello. Apologize we didn't get it to have in-person class sessions this week. Missing Tuesday, I didn't feel right about throwing the project at one class and not the other. Just don't feel like that's fair. So we'll push back starting on the project for a week. We'll focus on just talking a little bit more about form and function this week. And we'll hit back and get running next week. So this is just a light week for us, which I guess I'm okay with because snow days have made everybody's lives miserable, or enjoyable, depending on the type of person you are. This is my face. Forgot I was wearing that. This is how normative it's become. Ivana, it's okay. I'll forgive you today. But snackies are important. All right. So what we are going to talk about today is the idea of form and function. Okay. Now, last week I introduced the idea of a functional requirement, constraint, measures of quality. Those are all really important terms to understand, but so is form and function. Form, the idea behind form is, okay, let's say I need to transfer information from one location to another. You know, a cable is a form of something that does that object. I'm blurring out. I think I'm standing too close to the camera. I just picked up my whole class and moved it to the back of my office. It's weird carrying you around. Like, I know I've been working out lately, but like, she got those biceps, they're like ripped. That had nothing to do with class. So the idea behind form is that something physical has to perform an action, okay? I need light. There's physically a light bulb that does that. I need a whiteboard marker. There's physically a capsule that holds a material that also has a foam piece on the end of it. Okay, form is a physical construction. It can also be virtual if you want to talk about form as an algorithm. But it is a what? It is an actual, tangible, touchable existence of something that is capable of doing a task. And I'm going to say usually tangible, because again, sometimes it can be an algorithm. Like, tangible just means you can touch it, it's physical, it exists. This is all tangible. Okay, but the form it's the meat of what actually solves the problem. Okay, and on the other side, you have function. Okay, and now what function is a what gets done. Okay, so this is what does a task, and this is the what that gets done. Oftentimes this is a verb. It's an action. Okay, so when I talk about it, and let's say I need to go home. Well, the verb there is go. So the function is I need something that will transport me. As a synonym of go, I need a transport. Now, what does it mean to be a transport? Well, it's physically moving me. Well, I mean, a cannon does that. A train does that. A hurricane does that. A tornado. So there are lots of of forms, those are all forms by the way, that can accomplish the same function. Now, why are form and function important in design? Well, anytime you go to design something, and let's say, I need something that's going to teleport me from point A to point B, okay? Teleportation is the function. Where's the teleporter? Still working on that one. It's not tangible. It doesn't exist. If there is a function that can be done, there is a form that can do it. Okay? And that's a key takeaway here. Ran out of one line. If you heard that terrible sound, that was the sound of my heart breaking. See, Luke, same, but my cannon broke down because of the snowstorm. So what we have here, the importance of form and function, are now function in it itself sometimes becomes a requirement. In order to define a car, for example, one of the functional requirements is that it must move. Every car must move, and every car has to be able to carry a passenger. It has to have some way that it adheres a passenger to it. So two of the functional requirements of a car is that it has to move and it has to transport objects, people, something. And that's the definition of a car, at least how we understand it as consumers in our economic society. Okay, those are both functions. Now the form that we associate with that is, okay, if it has to carry individuals, probably has seats. If it has to move, it probably has wheels. Now we can also say, well, part of the definition of a car is that it has to have the constraint that it does have wheels. And specifically a car has to have 4 wheels, but it's getting a little bit out there. This is ultimately where design kind of is born, is understanding what is the function that is needed and what are the forms that can do it. Okay? There are a number of tasks. Usually the functions that are specified usually tend to be related to the problem. It's if you have a problem where you need to be able to close a gate, and that gate has to be closed remotely. Let's say it's a cow gate, and you have some kind of a system that monitors cattle as they move in, counts the cows, it ensures and scans to make sure that there are no cows outside the perimeter, and when that is noted, it drops the gate to prevent the cows. Well, I guess it would just close the gate, because most cattle gates swing open rather than guillotine. But it would close the gate and probably latch the gate at a certain point. Now, the function there is, I need something that closes a gate. I need something that causes a gate to go from an open state to a closed state. Okay? Form for that, I mean, there are pneumatic cylinders, there's electric cylinders, there's hydraulic cylinders, there are spring-mounted actuators, there are a bunch of different available systems that could do that. And a designer who's coming up with a gate closing mechanism, they have a lot of options when it comes to form, and that's a good thing. Usually what you will see is in the overall design process is understanding what needs to be done is critical. Understanding how to make what needs to be done happen is even more critical. Okay, so we look at just the overall design process. Okay, I gave you the engineering design process, which is problem framing, ideation, realization, analysis. In the overall design process, this can be looked at from a number of different aspects, and I'm going to write it another way here. Oftentimes, it comes with an idea of what's lacking, an inability, an inefficiency, in a realization of what a problem is, okay? And once you understand what the problem is, you have to understand what it is, what are all the tasks that need to be done that are either not being done or being done very poorly. And that's where you recognize function, okay? And this is, function is what needs to be done. What is it that actually has to be done? Once you understand all the functions, I should say functions, each one of your functions will generate a list of forms. Forms. Generate a list of forms. We got all the forms here. We're going to take our forms. We're going to learn from them, mate. Forget about it. Okay, once you have all these forms, then you have to find a way to cohesively combine all of these forms to produce a cogent solution. Okay? Now, what does that mean? Well, every problem requires multiple functions to solve. I'm hungry. Requires multiple functions to solve. I have to obtain the food. I have to prepare the food so that it is acceptable to my body. I have to consume the food. I then have to retain the food inside of my body. If those functions do not happen, my eating is in vain. So again, problem. I'm hungry. I have the hunger. Okay, functions that are required. I don't even know if I could maintain it that well. Terrible. I once did try to do Sylvester Stallone for an entire class. I was annoyed. It got bad. Okay, so the functions that are required in order to solve this problem is I need to obtain the sustenance. I need to prepare that num-nums. Okay? I need to then consume the deliciousness. And then I have to retain the word for food. Food. Stuffs. Ran out of cool words. Sebastian making a great joke. Yeah, I can't hold in that laugh. That was good. That was good. Clever. So these are the 4 forms that are required in that operation. Now, each one of these requires a physical, tangible solution. I have to obtain the food. Am I going to have to walk, or am I calling Grubhub? Okay? Nom-noms. I have to prepare. Is that going to involve cooking? Is this going to be something where it self-prepares, or it is made to self-prepare? I have to eat it. Is this going to be injected into my body? Is this going to be eaten normally like food? And lastly, I have to keep it in my body. Do I have the physical capability of not regurgitating this? Depending on what kind of food it is, no. Oh, I gag. I have the worst gag reflex ever. It's bad. Somebody handed me a piece of, it was like peanut butter and bacon sandwich. I almost barfed on them. It was bad. So anyways, these are 4 forms. Each of these have multiple tangible pieces that can solve it. And it becomes a microscopic problem solving at each step. How do we figure out how to do this? How do we figure out how to do this? And combining each of these, you could do a mini engineering design process on every single one of those steps. If somebody is having trouble retaining the food in their body because maybe natural processes are not allowing them to, is there a way to make it so that it doesn't come back up? Is there a way to design a process such that food does not regurgitate? Similarly, if somebody has trouble consuming that deliciousness, maybe the food delivery method needs to be adjusted. And maybe we need to go back and do a different preparation for the num-nums, okay? Or nom-noms, according to Ivana. We have a number of different pieces to this puzzle. And the problem with any real problem is that there are multiple functions associated with it. Okay? Every real problem okay, now why is that significant? Because here, every single function has to be addressed with a form. Something has to do the thing that gets done. I know that seems like the dumbest statement, but it's true. If you have a function that needs to be done, something has to do it. It's going to require a form. This is one of the reasons why engineers have a lot of jobs available to them. Is this whiteboard marker is not just whiteboard marker. I didn't go out into the wilderness and be like, oh, searching for whiteboard marker. It is a whiteboard marker time. And then I just suddenly, ha-ha, it's the whiteboard marker tree of life. And then I just pluck whiteboard markers off. I don't do that. This is a complex creation that involves multiple steps. It isn't just cutting a tree branch off of a tree and like, aha, stick. Every real problem has multiple functions associated with it. Now, some of those functions can be as simple as, I mean, you could solve a lot of problems with a stick, but the functions associated with it, you have to swing it, you have to move it, it has to have mobility. All of these different things, they're usually taken care of by the user. Swing. It was a French. Oh, you have found me out. I am in very great danger now. I will bring in all of the big guns to school now. No, I don't. I will bring my... No, I don't actually have a gun. I'm a terrible hunter. I only shoot with bow and arrow. I don't even have a bow and arrow. I only hunt with my bare fists. There we go. That's my French hunter persona. Okay, but every real problem has a number of functions associated with it. If you see any problem as being something that only has a single function associated with it, you're usually looking at it on too small of a scale. There are ways to improve every problem by looking at all of the functions associated with it. I like going back to the cell phone because within our lives, of course, it wasn't that aggressively. I only smashed him to the trash can. I would do the same to all of you. But any real problem, if you look at all the functions associated with it, they have a lot of different functions that go along with it. Okay, I like to use the example of the cell phone because cell phones are incredibly complex. Prior to the smartphone being created, cell phones performed one real purpose and a couple maybe secondary purposes. It was primarily a texting device and a calling device. The ability to transfer messages. With the advent of the smartphone, and I mean, yeah, you had devices like BlackBerry where you could send an email and it was horribly inconvenient, and it actually took years off of people's lives. My 7th grade teacher had a BlackBerry, and every time you I always felt bad for him because I'm like, I'm sitting over here like, I just wrote a word faster than you could type it on your tiny screen. Friendzone. Oh, that was good. That was good. So good, I think my camera just laughed. But with the advent of the cell phone, they looked at, okay, when you go to communicate with somebody, you have to obtain the device. This led to the invention of the smart watch, where now you don't have to pull the device out of your pocket anymore. You have it strapped to your wrist. The idea of you have to push a button in order to get the dialing now means you have voice commands where you can tell your phone what to do. All of these things were different ways of, different forms of accessing the same functions that we were already doing. It was just a reimagining of the functions that we took for granted. So often we get stuck in a rut of we have to perform X number of functions in order to solve a problem. And these functions have to have this one single form. But in reality, there are a number of forms to solve any function. And I use the term any here because that's really what it comes down to. Every problem consists of multiple functions. Every function could be solved by multiple forms. Looking at all of those forms together gives you a broad array of ways to solve that problem. You just pick and choose different forms from each function, plug them all together, and you have a solution. And all of this form and function contact brings us to the concept of what really is ideation. In the ideation phase of product development, what you're doing is you're taking the functions that you've identified as a part of the problem, as a part of the definition of the solution, looking at those functional requirements. In the context of the constraints that are given to you, like can't be gigantic or can't be nuclear or can't be radioactive, you're taking that context and you're putting it in the idea of we live in this world, in this real world. There are a number of ways to solve every one of those. So in the ideation phase, what you do is you take your functional requirements, you take all the functions that you've generated, all that giant list of functions, you take them and you figure out forms that are associated with them. Then you mix and match forms to come up with different solutions. And that's it. You're limited at that point by your creativity, your ability to perceive the functions. And not only that, but your ability to frame the functions in such a way that there are multiple forms. You'll notice I didn't just say, I said obtain the sustenance. I didn't say walk to the store. Because if I say walk to the store, then every time I am hungry, I have to walk. Nobody can walk for me. It has to be an action I do. And that limits it. Putting the functionality in the correct terms really opens up the definition of how we can approach this problem. And all of a sudden, I'm hungry can now be solved by Uber Eats, robots, I don't know, drone-mounted needles with IV bags. It's anything, just because I framed it this way. If you would have framed it, you probably would have framed it differently. But this opens up opportunities where now a very simple problem, a very common problem, can be solved in multiple ways. Using multiple forms, using different features. So, understanding the forms that go along with this oftentimes takes education. How many ways are there of retaining foodstuffs? Well, you can do medical research on how the human body closes Jerry, you're not supposed to post that in the chat. Hope nobody else realized that. It's terrible. I don't want to hit on my markers, and the quiz was completely legitimate. I hope that was believable. Okay, so in recap for this lecture, in order for you to understand the solution, you have to understand the functions. Okay? The functions drive the functional requirements. Because some functions are not necessary for an object, sometimes they're just measures of quality. But you will get functional requirements out of establishing the functions of a device. This also goes to measures of quality. So that it both defines what is the solution to the problem, but it also defines how to measure how good the solution is. But the functions ultimately drive the form. And the form is the physical product, the tangible solution that is used to solve the problem. And usually a complete form, such as this whiteboard marker, ends up being multiple forms put together. Okay? There has to be a casing here. There's a coloration here so that we know it's blue. There's a description on here so that we know that this is Expo Dry Erase Low Order Chisel. Conforms to ASTM D4236, made in the USA. I mean, it's even got this thing so that I can stick the cap in the end. The cap is designed to be easy to plug in. And it stays in place. It maintains the dryness of the tip. This isn't just one single element. I don't go out in the wild and find a whiteboard marker. This is multiple forms all put together in one device. Because somebody did the problem framing and understood what really was needed to make a whiteboard marker. Okay? So your quiz for this week is going to be about form and function. You will also have 2 modeling learning assignment quizzes. Those 2 you can take at any time. Yeah, you have a total of 3 quizzes, but 2 of them are going to be over AutoCAD. And the 2 AutoCAD ones, take them over and over again. Go for it. Yep, and then we will start talking about the project next week. You will have a reading assignment due, I believe you'll have 2 reading assignments due next week, because I didn't make one due today. You'll have 2 reading assignments due this next week. You have 3 quizzes due today. One of those quizzes is over lecture content. 2 of those quizzes are modeling learning assignments that are based on videos that I provide you inside of the quiz. If you have any questions, please let me know. But that's everything I have for you today. Have a good weekend. Good luck on your 1 quiz, 2 modeling learning quizzes, and 2 reading assignments due next week. We will have an in-person class next week. Not today, but next week. And again, I will send you out. We're probably going to meet in 233. I know the class is scheduled to be in 248, but we'll meet in 233, which is the bigger classroom because we kind of need the space. So I'll see you all next week.